Welcome to another episode of CSEC Math with Sir Kumar. Today we'll be looking at the perimeter and area of compound complex shapes. The first thing we're going to do is define what are compound complex shapes, and then we would go into the application of solving questions relating to compound complex shapes, that is finding the perimeter and the area of those shapes. So let's get into it. So the first thing we're going to do is to define what is a compound complex shape. In some cases, you're going to find these two words interchange. So sometimes you're going to see complex compound or you're going to see compound complex. It's the same thing. So what is a compound complex shape? A compound shape is a shape that is built up of two or more simple shapes. And in our previous lesson, we looked at simple shapes and we had a definition for simple shapes where it's a closed figure bounded by sides, bounded by straight lines, which we call sides. So when we look at compound complex shapes, it's just a shape that's made up of simple shapes, more than two, right? Two or more. So calculate the perimeter of a complex shape, we have to add the lengths of all the sides. So remember now there are more than one of them. So if you have shapes joined together, therefore you would have multiple sides that you have to add all the sides to find the perimeter. And to calculate the area of a complex shape, we have to divide the complex shape into simple shapes and solve. So again, more than one simple shape, we just divide up this entire complex shape into the smaller shapes and then we solve for whatever they're asking for. If it's the area of the general shape or if it's the area of a shaded portion of the shape, which we would be looking at the examples as we go ahead. So the first thing we'll be looking at is perimeter of compound complex shapes. So perimeter, just a quick refresher, the perimeter is the total distance around the shape. So you have a shape here. If you when you look at this shape, I can see that this is made up of more than one, right? So if you wanted to divide this, we just put a broken line here, and you can see right away we get two rectangles. But when finding the perimeter, we don't need to divide the shape. So let's take this out. What we should be concerned with is having the lengths of all the sides. And if you notice, we have a length here, we have one here, we have here, and there. But this side is missing, and that side is missing. So we have to now find the lengths of these two sides before we can go and find the perimeter of this shape. So the entire length at the bottom here, let's just imagine this is a big rectangle, right? And we can remember from the properties of a rectangle that the opposite sides are parallel and equal. So the bottom here is 10. That means up here should also be 10. So if we know that this little piece is 5, then we could find what is here. So this is 5. This entire thing should be 10. So 5 plus what would give me 10? So 5 plus 5 here would give me 10. So if we bring this up, we're getting the whole length at the bottom. And similarly on this one side, this entire length is 8. Therefore, this entire length here should also be 8. So if we know that this little piece is 4, then 4 plus what would give me 8? So it would be 4 plus 4 would give me 8. So let me take this out now. So now we have the lengths of all the sides of this shape. So to find the perimeter, what we have to do is we have to add them up. So let's go, starting from this side. So P is equals to 8 cm plus 5 cm plus 4 cm plus this part, which is 5 cm plus here, which is 4 cm plus across here, which is 10 cm. So P is equal to, let's just verify, we have 1, 2, 3, 4, 5, 6 sides. That means we must have 6 numbers. 1, 2, 3, 4, 5, 6. So all we have to do now is to add them up. And when we add 8 plus 5 plus 4 plus 5 plus 4 plus 10, that's going to give me 36 cm. So the total distance around this shape is 36 centimeters. Let's look at another example. So here now you have a shape. When we look at this, we see a square, and this is half of a circle. Now, they only give you one measurement, right? And that is, this one side is 6. So we have to find the perimeter of this shape. We know that, or we can remember that one of the properties of a square is that all 4 sides are equal. So if this is 6, then let's continue. So this side is also going to be 6 cm. Here is going to be 6 cm. And here is going to be 6 cm. So if I add around, I will get the perimeter of the square. But what happens with this piece? We still have to find the length of this curve, right? Or this, let's say this is a semicircle because it's half of a circle. Now what we have here is the diameter, and we have to find the length of this semicircle, or the circumference of this semicircle. So we can remember that the circumference of a circle is equals to pi d. And circumference is basically the perimeter we're finding, right? Which is the distance around the circle or the outside of the circle. So to find this, we have to use our formula pi d. But if you notice, we don't have an entire circle. We use this to find the circumference of the entire circle. We have half of the circle. So to modify this formula, we're going to say c is equals to half of pi d, meaning half of the circumference because it's a semicircle. So let's substitute our values. So c is equals to a half. We can remember that pi is 22 over 7 multiplied by my diameter, which is now this entire length here, and that is 6. Make this into a fraction, we put it over 1. So c is equals to, I multiply my numerators, which would be 22 times 6, and that's going to give me 132 cm divided by 7 times 1, which is going to give me 7. C is equals to, I divide, so I have a half of 132 divided by 7, that's going to give me 18.86 cm. So a half of 18.86 cm is going to equal to 9.43 cm. Now this 9.43 cm would be the distance from here to here. So let's write it 9.43 cm. Now remember we said that the perimeter is the distance around the shape, right? If you're going to look at it, we have, this is on the outside, this is on the outside, here is on the outside, and then we have this. That means we don't have use for this 6 because it is not on the outside, or it's not around the shape. So to find the perimeter, we have to add 1, 2, 3, 4 parts. So let's go. So the perimeter is equals to, let's start here. So it's going to be 6 cm plus 6 cm plus 6 cm plus this piece here, which is 9.43 cm. So the perimeter is equal to, when we add them up, we're going to get 27.43 centimeters. Remember that even though we have a square and a semicircle, you have to look at what is on the outside. This is not on the outside, so we can't use this part. This part is totally out. So we just add the distances around the shape. So we've looked at calculating perimeter. Now let's look at calculating area of compound complex shapes. Just a quick refresher. You can remember that area is the measure of surface. So in this question, in the figure above, each end consists of a semicircle. Calculate the total surface area of the figure. So when we're looking at area of compound complex shapes, we'll be going into 2 parts. So the first part is when we're calculating the area of the entire shape. And in the second half, we're going to calculate the area of shaded portion of compound complex shapes. So this one, they want to calculate the total surface area. That is the whole area of this entire shape. But before we go into calculating anything, we have to find our missing measurements as usual. So they give us the entire length of this rectangle plus the 2 semicircle is 45 centimeters. And they give us the height as being 20 centimeters. Now this and the width of our rectangle would be the same. So this part is 20 cm, and if this is 20 cm, over here is also 20 cm. We don't know what is this part as yet, but we will soon find out. Now, this 20 cm is the diameter of this circle. So if we were to put the center here and put the center here, then from the center to this radius, to this circumference, sorry, becomes my radius. So if the diameter is 20, then the radius is 10 cm. And same on this one side, from there to the circumference is going to be the radius, and this is also 10 cm. So if this entire part is 45, we know that here is 10, we know that here is 10, then we could find the length of this middle piece. So 10 plus something is going to give me 45. So 10 and 10 is 20, 20 from 45 is going to give me 25 cm. So now we know that the length of my rectangle, the width of my rectangle, and I now have either the diameter of this circle or the radius of this circle to work with. So let's go and find the area of this big shape. So the first thing, we have two semicircles at the end. If we put them together, one semicircle, two semicircle of radius 10, then this becomes one whole circle. The two ends come together to form a whole circle. So let's find the area of the circle. So we could remember that area is equals to pi r squared. A is equals to pi is 22 over 7 multiplied by r squared is r multiplied by r. We said that the radius is 10, so this is going to be 10 multiplied by 10. We make them into fractions by putting them over 1. So A is equals to 22 times 10 times 10, and that's going to give me 2200. Oh, I forgot the units. Anyway, we're at the units at the end. And then 7 times 1 is going to give me 7. A is equals to 2200 divided by 7, and that's going to give me 314.29 cm, and its area, so it becomes cm squared. So this is my two ends, right? Now let's find for the rectangle in the middle. So let me just put a little diagram of the rectangle we're looking at. So the rectangle, the length is 25 cm, and the width we found to be 20 cm. Width or breadth, right? Remember, it's interchange. The width, some would say width and some would say breadth. So A is equals to length times breadth, or LB. A is equals to the length, which is 25 cm multiplied by the breadth, which is 20 cm. Oh, sorry, let me take this out. So A is equals to 25 multiplied by 20, and that's going to give me 500 cm squared. Now, we found the area of the two ends, which is 314.29, and we found the area of this entire middle rectangle, which is 500. Now, this is not the end of the question. We have to find the total area now. So the total area for this shape would be the area of our circle plus the area of our rectangle. So total surface area would be equals to 314.29 cm squared plus 500 cm squared. This is going to give me 314 plus 500 is going to give me 814.29 cm squared. So we make a statement, hence the total surface area is 814.29 cm squared. And that's how you find the area of this compound complex shapes. Remember, break them up. Two semicircles give me an entire circle and a rectangle in the middle. You break them up, find the area, and then we add the area of each part to get the total surface area. Alright, so let's look at a second example. So the shape in the diagram is made up of a semicircle and a square. Calculate the total surface area of the shape. Again, this one is the entire shape we have to calculate the surface area for. And we have a square and we have a semicircle. Now, properties of a square, all four sides are the same. So if this is 12, this is also 12 cm. Here is also 12 cm. And this is 12 cm. The dot here with the O means that this is the center of the semicircle. So if this is the center, then this becomes our diameter, right? Because it passes through the center. So the diameter here is 12. Therefore, one piece would be our radius, and our radius is going to be 6 cm. Now, we know the measurement for all the parts. Let's start solving. So let's get into the solution. So the first thing we'll be looking at would be our semicircle, right? So remember that area is equals to pi r squared. But this is going to give me the area for an entire circle. But we're not working with an entire circle, we have half of a circle. So to get the formula for the half of the circle, all we do is half pi r squared. So let's start substituting our values. A is equals to a half. We know that pi is 22/7 multiplied by the radius squared. So the radius here is 6. So it's going to be 6 multiplied by 6. We put them over 1 to make them into fractions. A is equals to a half of 22 times 6 times 6 is going to give me 792 divided by 7 times 1 times 1 is 7. A is equals to a half of 792 divided by 7 is going to give me 113.14, and a half of 113.14 is going to give me 56.57. We're working with cm and its area, so it's cm squared. So this is the area of the semicircle, right? So this little piece up here is 56.57. Now we have to go and find the area of our square. So the square, we could remember that A is equals to L squared. A is equals to L is the length of one side, and the length of one side here is 12. So this is going to be 12 cm all squared. A is equals to 144 cm squared. So we found the area of the semicircle, we found the area of the square. So the total surface area will be the sum of these two. So total surface area is equals to 156.57 cm squared plus 144 cm squared. And adding them, I would get 200.57 cm squared. And we make our final statement, hence the total surface area is 200.57 cm squared. So a quick recap is that when you're finding the area, the total surface area of a shape, we break our shape down and then we find the area of our individual parts and then we add it together, and that's going to give us our total surface area. In our previous examples, we looked at the area of the total area of the shape, or the total surface area of the shape. Now in these examples, it's the same area we're dealing with, but we're looking at shaded region, right? Now if you look here, the first example, calculate the area of the shaded region. I have two circles, a big circle and a little circle. So when we're finding area of shaded region, for me, I personally say, you find the area of the big shape, and then you find the area of the little shape, and then you subtract them. So if you look here, our big shape is this circle with a radius of 15 centimeter. And our little shape is the inner circle with a radius of 10 centimeter. So if we find the area of our big shape first, and then find the area of our little shape, and we subtract them, we would find the area of the shaded region. So let's work this out and find the area of our shaded region. So the bigger shape, let's call it circle 1. And in circle 1, we have a radius of 15 centimeters. For me to find the area of a circle, so A is equals to pi r squared. We're going to use the whole pi r squared this time because we have an entire circle, right? So let's substitute our values. A is equals to pi, which is 22 over 7 multiplied by r squared. The radius is 15. So it's going to be 15 multiplied by 15. Put them over 1 to make them as fractions. A is equals to 22 times 15 times 15, and that's going to give me 4,950 divided by 7 times 1 times 1. That's going to give me 7. So A is equals to 4,950 divided by 7, and that's going to give me 707.14. We're working with centimeters, so my answer is in cm squared. So this is the area of my big shape. Now let's find the area of our little shape. So let's call that circle 2. So circle 2, the little shape, our radius is 10 centimeters. So r is equals to 10 cm. Our formula is A is equals to pi r squared. A is equals to pi, which is 22 over 7 multiplied by the radius 2 times. That would be 10 times 10. And we put them over 1 to make them into fractions. A is equals to 22 times 10 times 10. And that's going to give me 2,200 divided by 7 times 1 times 1 is going to give me 7. Dividing 2,200 by 7, and that's going to give me 314.29 cm squared. Probably working with cm. Now, this is the big shape. This is our little shape. So to find the area of the shaded region, I said that we're subtracting our little shape from our big shape. So we write the big shape first, which is 707.14 cm squared. Subtract 314.29 cm squared. And when I subtract them, I will get 392.85 cm squared. Then we make our general statement, hence the area of the shaded region is 392.85 cm squared. Well, you must note with this example with the shaded region and the previous examples with the total surface area is that with that one, we add our area for the individual shapes. And in this one, we usually subtract. So we subtract the little shape from our big shape. And as we do the other example, you're going to see we're going to take the same concept of subtracting our little shape from our big shape. Our second example, calculate the area of the shaded region in the diagram below. Now, in this diagram here, we have a square and you have a circle inscribed in the square, right? And they gave us one measurement, which is the diameter of the circle. And if you notice, our circle is touching the ends. So that means the diameter on one side of our square carries the same measurement. So if this is 28, then this is also 28 cm. And all four sides, this is 28, this is 28, and this is also 28. Now if you notice again, we have a big shape and we have a little shape. So our big shape is the square, and our little shape would be the circle inside of the square. So to find the area of this shaded region, we have to first find the area of our big shape then find the area of our little shape, and then we subtract them from each other. So let's work this out. So the big shape is a square, so let's start with the square. So we know we can remember that area is equals to L squared, where L is the length of one side. So the length here is 28 centimeters. So A is equals to 28 cm all square. A is equals to 28 times 28 is going to give me 784 cm squared. And this is the area of our big shape. Now let's find the area of our little shape, and that would be the circle. Area is equals to pi r squared. But this 28 here is not our radius. This 28 is our diameter. So first we have to do is to find what is our radius. So radius is equals to the diameter divided by 2. That would be 28 cm divided by 2. And my radius is going to be 14 centimeters. Now using this in our formula, let's substitute our values. A is equals to pi, which is 22 over 7. And if you notice here, they say take pi as 22 over 7. So they told us what to use. So pi is equals to 22 over 7 multiplied by r squared, which is going to be 14 multiplied by 14. Put them over 1 to make them as fractions. A is equals to 22 times 14 times 14, and that's going to give me 4,312 divided by 7 times 1 times 1 is 7. A is equals to, when we divide 4,312 by 7, we're going to get 616 cm squared. Remember our unit is cm squared. So our big shape, our little shape. So to find the area of the shaded region, we subtract. So area of the shaded region is going to equal to our big shape, which is 784 cm squared, subtract our little shape, which is 616 cm squared. Subtracting them, I would get 168 cm squared. So our general statement, hence, the area of the shaded region is 168 cm squared. And remember, when we're finding shaded region, it's our big shape. You find the area of our big shape, and then you find the area of your little shape, and then you subtract the little one from the big one, and that should give you the area of the shaded region. So let's get into the solution. So the first thing we're going to find is the area of our big shape, and our big shape is a trapezium. So A is equals, if you can remember the area for the formula for the trapezium, it's a half of A plus B times H, and A and B would be our pair of parallel sides, and H would be our perpendicular height. So let's substitute our values. A is equals to a half of A, which is going to be 80 meters, plus B, which is going to be 100 meters, multiplied by my height, which is going to be 30 meters. So let's work this out. A is equals to a half of 80 plus 100 is going to give me 180 meters times 30 meters. A is going to be a half of 180 is 90 meters times 30 meters. A is going to be 2,700 meters squared. So this is the area of my big shape. Now let's go into the area of our little shapes, which would be the rectangle and the circle. So let's look at the rectangle first. Alright, so we have, let me just write rectangle. And let me just put trapezium up here. So remember, this is my big shape and now these are our little shapes. So the rectangle area is equals to length times breadth. Area is equals to, our length up here is 56 and the breadth here is 14. So that's going to be 56 meters multiplied by 14 meters. A is equals to 56 times 14 is going to give me 784 meters square. So that's the middle. We still have our two circles to deal with. So let's look at our circle now. So the area for a circle, it's pi r squared. Now we have two semicircles. So if we bring them together, we're going to get a complete circle. So we're going to use the A equals pi r squared formula. And they said to take pi as 22 over 7. So A is equals to pi, which is 22 over 7 multiplied by our radius. But in this case, they gave us the diameter, which is 14. So our radius is going to be d divided by 2. And that's going to be 14 divided by 2, which is equals to 7. So my radius is 7. So let's use 7 here. So it's going to be 7 multiplied by 7. We put them over 1 to make them into fractions. So A is equals to 22 times 7 times 7. And that's going to give me 1078 divided by 7 times 1 is 7. So the area here is 1078 divided by 7 is 154 meters square. Good. So remember, these two here makes up my small shape. And this one here is the big shape. Now to find the area of the shaded region, we have to subtract the area of the small shape from the big shape. So let's find what's the total area for this small shape. So the area of the small shape, or let's call it, let's say the track, because it is the track, right? The area of the track is going to equals to 784 meters plus 154 meters. So it's 784 meters plus 154 meters. And that's going to give me 938 meters square, right? So this is the total area for the track, which is the middle. To find the area of the shaded region, that's going to be our big shape, which is a trapezium, and that is 2,700 meters square. Subtract the area of the track, which is the rectangle plus the circle, and that is 938 meters square. When we subtract the 2, we're going to get 1,762 meters square. General statement, hence the area of the shaded region is 1,762 meters square. So then let me go this back quickly. So the first thing we do is we find the area of our big shape, which is a trapezium, that is this big entire shape here. And then we find the area of our small shape, which would be the sum of the internals, which is the rectangle and the circle. So when you find them, you have to add them, and that becomes the area, the total area of the small shape. To find the area of the shaded region, it would be the big shape, which is 2,700, subtract the small shape, which is 938, and when you subtract them, you would get 1,762 meters square, and that is the area of this outside shaded portion. Now, the second part of the question, determine the distance around the track. Now, the middle here is our track, right? So let me just use this. Here would be the track. So they want to know the distance around this track. That would be on the outside, which is the perimeter. Now, let's extract this out here. So we have the rectangle in the middle, and then we have our two circular ends. So this is 14, and here is 56 meters. So the first thing we have to find is our two circular ends. Now the two semicircles come together would form an entire circle, and to find the length, the distance of around these ends, we have to find the circumference of the circle. So C is equals to pi d. C is equals to pi, which is 22 over 7 times the diameter, which is 14. C is equals to 22. Alright, let me cancel 7 1, 7 2s. 22 times 2 is 44. And 1 times 1 would give me 1. So the circumference is 44 meters. So this piece and this piece is 44 meters. Now, since we found that here and here is 44, remember when we are finding the distance, we can't include this side and we cannot include this side because they're not on the outside. So to find the distance around this track, it would be the length of our two semicircles plus this end and plus this end. So the distance around the track would be 44 meters plus here, which is 56 meters, plus here, which is 56 meters. And that would be equal to 156 meters. General statement, hence, the distance around the track is 156 meters. Remember, distance is basically perimeter, so it's the unit by itself. So remember again, around the track does not include these two, right? Because if somebody's going to run this, let's say they start here, they're going to run, go around, come all the way around, and then come back. So our two ends was 44 meters and then 56 and 56 at the top, and it gives me 156 meters for the distance around the track. To conclude today's lesson on perimeter and area of compound complex shapes, remember that a compound shape is made up of two or more simple shapes. Perimeter is the total distance around the shape. Remember, you have to get the length of all the sides in order to find the perimeter, and then you just add them up. The total surface area, you break the shape into its individual simple shape, find the area of each, and then you add it together. And the area of the shaded region, you find the area of our big shape, then you find the area of our little shape, if it's one little shape or two little shape, and then you subtract the little shapes from the big shape, and that's going to give you the area of the shaded regions.